Hello everyone, welcome to Hydra Book Reading Club number 16, I think. And in this series, I've been going through this website called Hydra Book, which I wrote some years ago, and we go through topic by topic. So if you're new to Hydra or if you're not familiar with some of the functions, I highly recommend to go through the beginner's tutorial and intermediate tutorial that I recorded before, or you can just watch them and just have the sense of like what you can do with Hydra. But also like just note that in this particular chapter, custom GLSL, we're using the GLSL code, which is not JavaScript, which is not Hydra, and I'm not gonna explain all the details about GLSL, so I assume that you know some basics about it. Well, I'm not really like expert in GLSL, so I'm also like exploring, just changing things. Um, and for that, I don't have any tutorial for GLSL. So if you are curious about it, probably you can find some other channels that offer that kind of tutorial. But let's begin. We have already looked into the source and geometry, which is called type chord inside Hydra. So we're like really like digging into like a deeper level of Hydra, which is kind of like a bit more like a danger zone. And I'm a little bit excited today because now we can go through this example, well, this one, for example, this chroma key that I also use sometimes in like some cases, which is a custom function I created for working with the green screen. Well, this green screen is actually, I have green screen here, and it's not processed with Hydra, but it's processed with OBS, so it looks different. But let's see what we can create. And I'm gonna just like make myself smaller, and always we work with Hydra editor here, and I'm gonna just raise this. So just like in the last examples, I'm gonna like use this function called set function to define my own custom GLSL. And I'll just start with something like very simple. For example, like let's take a look at Luma inside GLSL functions. I also put a link to this source code called glslfunctions.js in the description down below, where you can find all the other like default GLSL or like Hydra function like OSC, noise, scroll X, modulate, everything's defined here, and you can actually read what is like happening under the hood with GLSL, how Hydra is processing these things, combine these things to create visuals. So if you take a look at Luma, I'll just like copy everything from this object and just copy it, paste it here. So now I can define set function. It's a little bit, quite a lot of like lines. So I'll just like try to compress it a little bit so it fits in one screen. I'll try to like just compress them here. And inputs, again, they're kind of important in some cases. Okay, maybe it's a little bit harder to read now, but it's okay. Maybe this new line is actually needed. So we have this type float. So there are two float inputs. Well, we know Luma, right? So the first input is threshold, and the second is tolerance, like how the blurriness it makes. So it's not always like harsh cut off, which is going to be like 0. If you set it like 0 0.5, 0. 0.5, it's going to be like a bit more blurry edge that you can see. And this is the code that makes the Luma effect. And it's a little bit like harder to read now because it has this smooth step, which is basically a way of making this like thresholding. We can keep it actually very simple. Like maybe we can like edit it. Okay, but also just like how we did in the last videos, I will define Luma. Okay, maybe I can this time I can do like chroma, but also I have chroma in the example. So maybe I'll just say like Luma 2, so that it doesn't pollute or contaminate the default Luma, because if we start editing the code with this Luma, then it will overwrite what is Luma like offered by Hydra, and we don't want that. So let's say Luma 2, and let's see, like, what if I just take this second parameter out? So I just work with the first parameter, the threshold, and let's kind of simplify this. So we can like always use if statement, right? Which is not really preferred by like good GLSL code, but we can do that too. It's okay. It's for demonstration. So what's important here is that I just copied one part, which is like luminance, and this underscore luminance. So it's just a convention, but what starts with underscore is something provided. Well, not always, because time doesn't start with underscore, but it's like a convention that underscore luminance is something that is not Hydra function, but it's in the Hydra code base for GLSL specifically, because this luminance is used in different places like Luma, Thresh. We can also search inside this code. So it's used in Luma, this is Thresh, this is Mask, and goes back to Luma. So those three functions, Luma, Thresh, Mask, they use luminance. So instead of like this basically conversion from RGB to a luminance value, which happens repeatedly, so there is a common function called underscore luminance, but it's not exposed to Hydra. So if you're like just writing Hydra code, you will not see this, but under the hood they refer to the same function called underscore luminance inside Luma, Thresh, and Mask. Now what it does is basically it converts RGB, this vec3, into one float from 0 to 1. Well, most of the case, but depends on how big your RGB is. But if you give normal color, then it will give a luminance of like 0 to 1, basically like grayscale. But it's not just like average of RGB. I think it's like converted to like how human perceive colors. I'm not so sure, but some kind of color space conversion. And basically we'll do something very simple. And because we're talking about Luma 2, it doesn't have this tolerance, and we'll just keep it very simple. So if the luminance is above 0.5, or actually this is the threshold, this refers to the input value threshold. And if this is the case, A is 1.0. So this is going to be opaque. Everything luminance below the threshold will be A 0, because its default value is 0 here. And I compile this, and again I have to open the console because it doesn't show the error if, well, these are not the error that is coming from what I just did, hopefully not. And if I do OSC Luma 2, our new function, and if I don't give any parameter, it will take this default value here. And let's see. Okay, so it is giving an error. Why is that? Because there's syntax error. Oh, because I put the semicolon here instead of here. So this is like illustrates, I mean, it's just happened by mistake, by chance, but if you have a syntax error inside GLSL, it will not show immediately after evaluating set function, but it will generate error when you evaluate the code, and it will not show in the console down below of the editor. You have to open the developer tool console on your browser, where I'm sitting here, and this will show like WebGL warning, and then you can debug the code. And just to make sure that this is like Luma, not just black color, I can do like solid 100, or I don't know, gradient. Today I feel like more like gradient, and layer this new OSC in Luma, and let's see that it actually does Luma thresholding, but in a different way from how it's defined as Luma, which uses smooth step, which is kind of cool way to do thresholding that also can blur some color. But instead I just did like very simple way of thresholding, which is basically the if statement. So we can do something very simple with chroma. Like if we want chroma, then maybe I should do like gradient will be like passed to, let's say like chroma 2, like because this is kind of impersonator of chroma, like because proper chroma keying has a bit more like, it's not that simple as just taking the green channel, but let's say like it's chroma 2 and chroma 2. So the idea, like what I want here is that only this green part will be cut off of gradient. So if I don't have chroma 2, this is normal gradient, I want just this green part to be like taken away. And what does it? So this is like, I put chroma 2 here, but this is basically Luma 2, right? What's like the same as what we defined. And this is not desirable result. First of all, it's not cutting off green part, but also like it's just taking the darker color out. So this is not what I want. What if I just say naively, so underscore C0, just like underscore luminance, underscore C0 is given by Hydra, like input, like pass to this function chroma 2 chunk of code, and this is basically the color of the pixel. And we want to like convert this underscore C0 into something. And underscore C0 is color of like 4 RGBA, which we can change, morph, or whatever, mutate, and then return vec4, which is also a color. And this will be the new color. So this is very like simple, like intuitive to understand. I think you just like get the underscore C0 like a color and generate a new color, return it. So it's just color conversion. So if you want like make it brighter, you can also like return underscore C0 times 2 and make it just brighter. We can just try it. This is not what I am gonna do right now here, but I mean, it's not my objective, but just for demonstration, if I do something like this, it will just make everything brighter. Or if you want to like divide it by 2.0, this is a very simple way because now it's also dividing alpha, so it's actually dividing more than 2 in terms of the luminance. But these things you can do, like you can like experiment quite, it's really intuitive. I think working with type color, these functions is very simple. And also you can do some funny things like swapping red color and green color. How can you do this? The easiest way, you can also like make float number and pass it, swap numbers, but also there is a way to do it elegantly in GLSL, which is instead of RGBA, you can do GRBA, and it will just flip red and green channels. So you see this flipped, transposed gradient. And you could of course do something like this with scaling and whatever. Anyways, that's not the point. What I want to do is just like go back here. I want to make some kind of, oh well, this is different now. Okay, because now what I want is just take the green color out, but this is not what I want. Green color out, not when green is brighter than the threshold, I'll keep this, but if the green is bright, I want to take it out. I don't want the green color. Now this is like, it's getting there, the green part is like gone, but also it's taking this yellow part out as well. Why is this? Because now we're not like taking care of red channel and blue channel in this case. So if the green channel is bright, it doesn't mean it's green color always. It can be yellow or white when R and B channels are also bright. Then, if RGB all are 1, of course green channel is really bright, but it's not green color, it's white color. That's how color addition works. So in the RGB space we're working with, So this is not what I want here exactly. Like I want somehow to like detect what is green, but like not white. And I think if you go to like this example by Inigo on Shader Toy, this is basically the code I'm showing here is on the Hydra book. It's basically like the best way to do chroma keying based on this Inigo's example. I just like converted it to Hydra code, so you can just like copy and paste and use it. And I'm not gonna like, because this has some math that I don't really understand. I just like naively ported the code. Here I can just do something like simple. For example, and I don't even like probably need to work with threshold for now. Just forget about threshold. And let's say like I just want to do something like, what if I'll take this like difference between green channel and red channel, but also blue channel. So maybe I can take average of red and blue underscore C0 dot red underscore C0 dot B divided by 2.0. And if this is bigger than, I don't know, it can be this can be the threshold, right? Then it means that green channel is, and also I need to like flip this logic so that it's more coherent. So the default alpha is 1 now. It's opaque always, but the condition that is like green channel is like more prominent than this red and blue, this more like manifesting than other channels, average of other channels, then it's most likely it's green. So we'll take alpha 0 for those pixels. And let's see how this goes. Oops, so there is an error, so I should not do this. So what was the error? It was flickering, so I just like put some random code here to stop it. So underscore, it doesn't really show what the error is. Oh, because I said thresh instead of threshold. Rookie mistake. And do it again. So I think it's like okay-ish. Like I would say like this green part is also like should be thresholded, but maybe like I can just tweak this parameter here if I want. But also like it's still cutting this yellow part off, so I'm not really sure. If you really want to work with like proper chroma keying, I highly recommend just checking out this code. I'll just do it here and compare how it is. Okay, but it's kind of close enough. I think this looks like visually it's more convincing that it's cutting off this green area. But the one I created right now, just naively by taking the average of red and blue, it's okay. It's not, it can be better, but it's like okay. And what I really want to do now is to like check S0 init cam, and I will set this to my FaceTime camera, and I'll just take source S0 because now I'm facing, well, the behind me is green screen and OBS is doing this green screen chroma keying, green screening. But then what happens with this is, okay, this is not really working, right? Because chroma 2 is there, but not thresholding this. I'll take like solid 001 and layer. Okay, it's not doing it, but don't worry because I set this threshold value. So if I set like 0.2, okay, it works. It's kind of okay. And you know, you see this like edge is like quite harsh in this image because I didn't use smooth step. And in this example, I suppose, oh, actually they don't use smooth step, but they do some kind of blurring because you don't want this like really harsh edge here. So that's something like up to you if you want to like properly do it. I guess like you can just combine my take on chroma keying with smooth step instead of like if statement to make it a little bit smoother. That's also possible, I think. But but I'm not gonna go into that because that's just like GLSL coding. And I really wanted to like show you like how this set function with type color can be used in Hydra. All right, so quickly I will just like go through also another family of Hydra functions, because we have spent quite a lot of time with like source, one video for source, one video for geometry. Now I just covered color, and also I want to talk about blend quickly. Now the like famous function for blend is blend, I guess. So let's see, name blend is here. And blend is, that's the name of the family of functions, like when we speak about it. But inside Hydra, it's defined as type combine. Just like geometry functions has this name called type chord. It's type combine, and guess what? The modulate family, they're defined as type combine chord. So it's actually a combination of like blending and chord, like geometry functions, which kind of makes sense because modulate is actually kind of doing, it's not actually blending, but it's like taking two textures and manipulating the coordinate system. Well, the coordinates of the pixels. So I guess we can just like start with like blend, because now we see it here, and as always I'll just take this. I'll probably just like keep this code as it is. I'll just evaluate everything, so I can put this link into the description down below, so if you open this it will automatically show you the chroma 2, like my naive take on chroma keying. And I'll just open new Hydra editor and clear this one. Now I will just do set function again, and I'll paste what is inside blend, and as always I'll just do blend 2 so I don't contaminate the blend function itself. Now the usage is basically the same as blending. How we do it is we put something inside here, let's say Voronoi. So if we do this, it's not, I'm still not taking blend 2, and I will just stop all these like movements because it's a little bit distracting. Like this. Oh, it was like, is default like 6 or something? I don't know. Anyways. And I'm not using the blend, the new blend function. The new blend is blend 2, and this evaluates fine as well. Just make sure that it's the new blend function. Yes, so blend 2 is working. Now let's look into the code. Always this GLSL, which is just a string inside set function. This defines the GLSL code that will be passed to the compiler after, when it's like, well, the Hydra engine will compile all these functions, like chunks of functions from OSC, blend2, Voronoi, and then make a complete GLSL code and pass it on to the GLSL compiler that will generate the visuals. And this is quite simple. It's just a return statement which says _C0, which is already we're familiar with the type color. It's just the same, that it will get the color of, is it the one that is coming from, let's say, because now if we say the amount, this is the parameter, if we say the amount is 0, then it's completely OSC, which is like the preceding one. So the amount now is 0, so _C0 is the one that's preceding, which kind of makes sense, right? That comes before blend 2, and _C1 is the one inside blend 2. So now instead of like we're taking this _C0 and generating new color, which is also possible, like we can just say like, okay, just screw it up, _C0, like we don't care about _C1. That's also possible. This is basically, okay, so I didn't put this one here. Yeah, this is also possible now, like whatever amount I say, it will just pass through OSC, which is _C0, which is quite useless, but I just wanted to like demonstrate that this is possible. Also, if I say like underscore C1, then it will just show Voronoi was inside here. And we can always say like, okay, what if I just say like underscore C0 plus underscore C1? That's also possible. That is like basically add. It's not exactly add now because we're adding this alpha channel as well, so it's not really desirable effect. And if you look into the example here, let's search for the add function. Yes, this is also combine. It's doing a little bit more elaborate thing because now we don't want, oh, actually it's basically the same. It's not taking the alpha channel into account. So basically it's adding C0 and C1, but also like it has this amount value, which basically makes the effect of like underscore C1. It's a little bit confusing. I think it's just basically like multiplying underscore C1. So if the amount is 0, then it's just C0. And if you gradually add the amount, C0 is always there. I think this is a kind of weird way of writing addition. It's basically, we can recreate it here. Basically what it does is times amount. Yeah. So if it's 1, if the amount is 1, it's just like pure addition. If it's 0, then there is no amount on this one. And you can also like have multiple inputs. So you can have like amount 0 and amount 1, which multiplies to underscore C0 and separately to underscore C1. All these things are possible. It's just like what Hydra offers by default is something that is like basic that you can work with, but also like these specific needs, if you have specific needs, you can create it on your own. But also if you just want to like multiply something to underscore C0, you can also do it with color function here instead of like writing this new function that will take amount 0 and amount 1. You can do it with Hydra. So always like think about like what's the counterpart. Is it possible with default, a combination of default parameters, or is it something that you definitely need to define a new function? And some things you definitely need to define a new function. For example, like what if you want to take the maximum between C0 and C1? Something like this. And I just don't need the second parameters for this case. And this is something very particular that it may be possible with default Hydra functions, but it will be like super lengthy. You have to like really think about like how to do Luma properly that is affected by Voronoi and OSC, and I'm not sure if it's possible with this, but just defining this, and you can also name it as like max function, or like if you want to do like min. These things are like really like, if you work with like Photoshop, it's like darkening, or I don't know how it works, but this is like layer, like how to combine layers, right? It offers like whole bunch of lists. If you open Photoshop or GIMP, it offers like different ways of like combining colors, and combining colors, basically that's what you can do in this set function with type combine. And also like color burn and all these things. You can like search for like Photoshop filters or like Photoshop layer color, and then you can find all the math behind it, and you can just implement it here like this. This is a very basic example. And if you're not sure how to do this, but if you just want to use it, there's also like a whole bunch of plugins that, or like extensions that the community members made. For example, Geika made this Hydra blend, which is, I think it's still on glitch.com when I'm recording this, and I'm already in touch with them, how to like port it somewhere else. So hopefully when this video is out, it's hosted somewhere else and everything's tidy. But basically, like if you put this, just like open the link, and then it's actually on GitHub, and like they offer like darken, multiply, color burn, exactly like, for example, like what I did with minimum maximum is probably one of these functions, and you can just like put it in and use them. So that's one way, another way of doing it. But also basically what behind the scenes, like Geika did write all these like set function with different combinations so that it's inside that script that's going to be loaded as an extension, and you can use it. So if you want to like just use it, you can like go through different extensions and try them out. If you want to like really dig into it, if you want to know how it works, and if you want to make your own filter, then you have to start digging into set function and how to write GLSL. So that's it for now. And in the last video, the last video hopefully, I'm going to talk about how to work with modulate, which is combine chord. The last family, I know there are like different functions, but basically what are the functions that are defined with set function? There are like only these 5 families of functions: source, chord, color, combine, and the last one, combine chord, aka modulate. So stay tuned, and I wish you happy coding. Bye.